Hello, this video is to show you a short demonstration on how to build a decision support system for circular economy. The case study here is to use a coffee machine, to monitor the part and the components of a coffee machine and see how much value you can derive from that. The program is written in Python and it is simple. You will receive this link, and once you have received the link, just click on it. This is how the link would load. You give it time. So there's a bit of information here, like if you want to know more in details and understand the work, there's a paper published on that. This is the paper, is linked right here. You can click on that and read it on Wiley Library or on Google Scholar. The paper is there, and so that you get more detail, because this video is not intended to be long to cover every explanations, but it is only intended to show you that this thing works, that with technology you are able to generate data and analyze the same data to make informed business decisions that can drive value using the principle of circular economy. So is circular economy decision support system a demo here? Just follow me along. The programs is written in Cell. So it is on Google Scholar. It is written in Python, but you don't have to install any Python locally on your machine to run this program. All you need to do is once you click on the link, it will come up like this. You will be asked to log into your Google account before you run it. So the first thing I would advise is to log into a Gmail account if you haven't done so yet. And once you log in, make a copy so that one copy will be resident on your Google Drive account, and anytime you can always go back to it and you can modify the code, play with it, and save it. Because if you play with this code the way it is, anytime you log out or you close it, when you come back, the changes will not be saved because it is saved on my own Google Drive. It is on the cloud. But if you want to have your own copy that you can play with, make a copy and then save it on your Google Drive, and I will show you how to do that. So if you look up here, there's a tab called File here. Just click on that, then you come down here, it says Save a copy in Drive. So click on that and wait. It will be saving a copy in Drive, and then you should open it in a new tab. So now the name has changed. You can see that the name has changed from what it was to copy of CE tutorials .ipynb. Now you are ready to start running. So the first step here obviously is just more information, the title, and then the paper and the authors of the papers, which I recommend you look it up. And the next thing here, we will look at the library. So let me give you just a brief information on how this thing works or how important it is. So before you buy a product, if it is fairly used or somebody has used it before, you want to know how long they've used the product, what materials are used in making the product, and how much life is left in the product. You want to know its durability and its the rate at which this product may fail, so that you know how much you want willing to pay for it. And the businesses are also needing this kind of information, so that if they have this information at their end, even though the product has gone out to be with the user, once it's returned to them, they can still remarket it and create value from it. So this is what this program is all about, and it is written in the simplest of format so that anybody can understand it. You don't have to understand any programming to be able to run this. I will just show you what to do. So the first cell here, you don't need to click anything, scroll down. The second cell here is also giving you information that we need to install some packages, and all you need to do is bring your cursor here over the cell. You see that there will be a play button here, so click on the play button and wait. It will be connecting. If you check up here, it will be connecting to Google Cloud, and then allocate some RAM and some disks for you so that you are able to run this program. And it is now installing this Python because these libraries, but because I've used it before, they are already installed. So you may want to click. Sometimes the libraries come installed, but if it's not, then for the first time you need to run it. For in my case, it is saying requirement already satisfied for all, but in your case it may download and install them, but it is important that you click on that first. So this next cell here is to import the libraries that you just installed that will be needed later on in manipulating the data, and then to also generate data. And here there are three lists that are created, which will be converted to a data frame, with 3 columns. And basically, what it means is that this data is supposed to be received from a sensor, from the device itself on real-time basis, because that is what the IoT project is all about. But for the sake of demonstration and for simplicity, we're generating the data here, and we're only generating 10 items. But in real life situation, you may have 1,000, hundreds of thousands, or even millions of thousands, millions, and distributed in different locations. So these products are performing at different rate by different users under different conditions, and so you'll be having more data to analyze. So you may have to but you have to write some sort of machine learning algorithm to determine what is happening to what product and how much value is left on such product and what time are they likely going to fail. So much thing has to be put in place, but for this purpose we are only basing on 2 factors: the use cycle, which is represented with USC here, and the life cycle, which is represented with life C here. So the use cycle is the number of times a product is deemed to be used before it can fail. So, and the life cycle also is how long the product can stay before it fails. That means even if it is not used, every product you see in life, including buildings and whatever, once they are made from materials, the materials have life cycle, and this life cycle affects the product that are manufactured from the material. So you need to know the life cycle of the material, and you need to know the use cycle of the material, of the product as well. And that is why we're saying that with the help of technology such as IoT, you are able to track this data, and then with AI, machine learning, you are able to analyze the data and then make informed business decisions. So this program is written simply without involving all of those, the machine learning aspect of it, because it will be much more complicated, and it is out of the scope of this demonstration. So now you've seen this cell here, so you want to click on this to run it. If you click play and wait, it will generate the data and give you this sort of data frame, a nice table that the data is simple and it's easy to understand. Like I told you before, it's only 10 items, like POM 1 to POM 10. And if you click on this icon here, it will convert to a simple table that you are able to now at least play with it. So if to say you have up to 100 or 1,000 of it, and you want to look at only poem that fell under a certain category, you are able to click on filter here and do that. So maybe the life cycle here, you may just want to view those that the life cycle is between 1 and 4. So these are the products that are under life cycle 1 and 4. And you can also use instead life cycle use cycle to filter, or you want to use the name to filter, or the index number here. So it's up to you, but I'm just trying to show you how even with this you're able to manipulate, despite the fact that we just generated data. We have not done anything yet on it. Now the next cell is to determine the classes of each of the product that you've seen. That is like a kind of classifications based on rules. So we have a rule system here. The decision support system here is actually a rule-based system that classify you, that tells you that, okay, if this product has been used 5 times and it still have 3 years left, then it belongs to this class. And these recommendations comes from expert, because it's a work that has been going on for some time, and you will find more detail on the paper that is linked in the title of this work. Now if you don't have to understand how this code works, but all you need to do is just click here and run it, and then you will see this table coming up again. You can also click here to convert it to a table that you're able to filter and see certain things like that. If you click here now, you can be able to filter them, maybe view only the one that belong to a certain class like that. I want to view those that belong to reuse alone, the product that are under reuse. So you look at the three of it here, and these are their data. And I want to also maybe check the one that are under cascade. Once you start typing cascade, you see they are coming up. So yeah, you can take your time and play with them. It's really simple rather than having to scan through the name of the classes to see everything. So let's move on. The next class is sorry, not the next class. The next cell here is on creating assigning the classes. So we've already assigned classes basically, but here we want to assign the returns on sale. So the return on sale is the potential value that you can still derive from a product even though it has been used for some time, and by getting them back and then remarketing maybe through the secondary market or to a secondary user. So even if you don't understand the rules, just click the play button here. Make sure you are not skipping any of the cells. Follow it logically by playing them before you go down. So you still get this data like this. So you have the first column is still there, second, third, fourth, and then a fifth column has been added here, which is rows, like I said, in percentage returns on sale. And this are the potential return on sale. The calculation is not shown here again because it will make this demonstration complex, but if you look at the paper, you'll find more details there. And so the next thing you want to do is to know the locations of this product, because they are not used in the same location. They are not in the same house. They are used by different households in different locations. So for instance, in a particular country, some of the product might be in London, Manchester, in Birmingham, in Glasgow, some may be in Portugal, everywhere there. So with the help of connectivity, that is why it is important. You can tell their location based on the sensors that is attached to them. So this is a simple demo. We're attaching longitude and latitude here to determine the location of this product here, just for the purpose of demo. So click on this button and run. Then you go down. You see that the data frame you have before has now 3 additional columns. The first one is your Y, X, and then smart home. This X and Y and X represent the longitude and latitude. Meanwhile, the smart home here tells you the names of the home, and obviously there are users in it. So you also want to know like how many users are in each house and how much pressure are they exerting on the product they are using, because all of those factors are important, but we will not be bringing in more so that it doesn't look so complex here. We'll stop here for now. But the next thing we want to do is to visualize this data now and see how many products belong to which class and how much value is left on them. So one of the easiest way to do that, like we all know, this is already looking complex despite the fact that it's only 10 items on this data frame. What if we have 100 or you have 1000? How are you going to be looking at? So the best way is to find a convenient way of visualizing it. That's why we're creating the first visualization. Just click on the play button again and see what comes out. Give it some time. So this is what you have. So on the vertical column here, you see your returns on sale, and on the horizontal axis you have your pump. So each of these bar represent pump, and you can see the names are under it: pump 1, pump 3, and the height of the bar tells you how much rows you can get from each of the pump, like pump 8, pump 7, pump 4. They're the one that have higher rows compared to those of pump 1, pump 3, and pump 6 here. And so yeah, it makes things easier for you. So even if there are thousands of them, there's a way you can group them. Maybe the next one will show better. So let's create another visualization here again. Once you click, you wait for it to run. So the rows is still on the vertical axis. On the horizontal axis now is the class. So the class is here. So the class recycle have 1, class cascade have 1, and then we have remanufacture, repair, and the rest of it like that. So you look at it and then hopefully you're able to understand. But again, you can just put your cursor on any of the bar and it will give you more information. Like, okay, this bar is pump 10. The ROS is 53. The class is the manufacturer class. The life cycle is 3.9 years, and the use cycle is 14,800. And you can do that for any of the bars. And the same thing apply here as well. Like if you check the first one here, is the class is remanufacture. So both of these, they're on the same class. This class is remanufacture, they're remanufacture, but then the rows here is also going to be the same, but the name will be different. So this is pump 10 and this is pump 5, and the use cycle is 1. No, the life cycle is 1, and the use cycle is 14,600, but this one is 14,800. So yeah, just play around and then see how you do. Let's create yet another visualization and see what it looks like. So this gives you a kind of summary. Imagine that you have 1 million products out there, and you want to just have an overview of these products, which classes do they belong to, or which class have more of the product, or most of my product will be classified under which class. So if you do that, you can see from this chart here, this pie chart, and using this legend here, you see that you reuse, which is blue in color, have 30% of the product. Meanwhile, the rest have 20%, 20%, 20%, and then one has only 10%, which is recycled. Yeah, so that is how it works. It's easier to identify. So now the next thing is to know their location. Look at them geographically. Where are they distributed? And to do that, this is the map. Like, you don't have to bother about the code. Just click on this and play it, and give it some time. So you see the map comes out here. Initially there wasn't map, but when you play, the map will come out, and this is what you have. You can zoom in and zoom out, bring it closer so that you see the names of the places around. So here you have the name of the street, and you click on it, it will tell you which home is that. Oh, this is home 10. And so if you go back to your data, you know, you will be able to know which product is in home 10 and what are the other characteristics of the product. And here is home 9, just like that, like that. This is Bradford's map, the map of Bradford. This is used for illustration, but you can, if you know how to play around with it, you can change it to represent the map of any other country of your choice. But yeah, we've just used the city of Bradford map for the purpose of illustration. And the last thing here is another visualization again, which might be complex and you may not understand, but if you understand it, fine. It's just classifying everything based on their rows first, and then their classes, and then you see the name of the product coming up here. So if you click on it, it's able to open to give you more details, like that, or you can return to the original format like that. But yeah, so this is the end of the demo. But just before I stop, if you come up here, you'll be able to see where you can play with the data. So up here, if you know the longitude of places, if you add here, if you change them here, it will reflect, but that's not what I wanted to change. What you want to change is, maybe this is only for 10 products. You can increase it from 10 to possibly 20. You can increase it to 30. You can increase it to whatever you want. For instance, here, if you want to increase, just add a comma, then put the name of the product after typing in your either double quote or single quote is fine. Then you put pump 11, and then the pump 11 also need some data attached to it. So you also use, you don't need any quotation mark here, just enter the value because it's integer basically. So you can say maybe it's 13,000. The life cycle is 13,000 times, and then come to the life cycle column as well. Click on that, and maybe it's 2.5 years. And then if you run this cell now, you will see that we now have pump 11 added, 13,000, and then 2.5, and you can keep adding to 10, 20, or whatever. However, because these rules are written just brief, because you need more rule to cover every possible scenario, some of the product when you add and you now run this rule, it may display 0. That is to say that the value you have entered is not covered, and that is why you may need more complex system to handle this job. Things like fuzzy logic, you may want to use machine learning to do that. But for this level, this is okay for now. Happy to take your question. If you do have a question, post it in the comment section. I will reply. Thank you. Bye.